So today we're going to take notes on the spanning trees part of your notebook. So find that page and follow along. And you may need to pause or rewind this video from time to time. You will need a highlighter. So in this problem, an oil company is going to install pipelines between storage facilities in order to transfer oil between any two facilities, either directly or through another. The graph shows all the possible pipelines that can safely be installed. Find a set of pipelines to accomplish this without waste. So really we're just going to pick a place to start, and we'll be done when we have a tree for this graph. So I'm going to start at this vertex here, and I am going to highlight, actually I'm going to change the color so it's easier to see. I'm going to highlight the highlighters aren't showing up very well. We'll just do it in. I'm going to highlight that one. And then I'm going to also highlight this one. And I'm going to highlight this one. And this one. And this one. Now I just randomly picked those. But we have a tree because there were 6 vertices and we've highlighted 5 edges. So that's as easy as finding a spanning tree. That's not a very good method. It's just a quick and easy method. There are some better ways to do it. So, a spanning tree of a graph is a tree that uses the edges and vertices from G that contains all the vertices. And one way to do that is to just eliminate cycles by getting rid of edges. So, we have a cycle here, this triangle. And we can pick one of those edges to get rid of. I'm going to get rid of this one. So we're going to cross it out. And then we still have a cycle, this parallelogram looking thing. And so pick one of those edges. I'm going to pick E to get rid of. And what's left using edge A and C and B is a spanning tree. It gets to all the vertices and uses edges that were in the original graph. But sometimes it's hard to find all the cycles because most graphs don't have just 4 dots. So we need a better method. And the better method is one that should be kind of familiar already to us. And it is the breadth first spanning tree algorithm. It's a lot like the breadth first search algorithm that we've already done. We're going to pick a vertex to start at. We're going to label it 0. We're going to check to see if we're done. Are all the vertices labeled? If yes, we're done. If no, we go to number 3. We're going to label all the adjacent vertices with the next number. And we're going to highlight the edges. And then we're going to go back and see if we're done. So we did this algorithm in the previous unit, but instead of just numbers for the labels, we also added the predecessors. Since we're highlighting, we don't have to do that. So let's see how it works. So we're going to be finding that the breadth first search from A. So A gets the label of 0. And then we're going to go everywhere we can. And I am going to highlight first. And then label. So I can go to B and I can go to F. And they will both get 1s. Then, which comes first, B or F? B. So I'm going to highlight from B. And the only place I can go from B is G. And it will get a label of 2. And then I'm going to highlight from F, and it can go to L and to M. And they'll both get 2s. And then I look at all the 2s. G comes first alphabetically, so I'm going to go where I can from G. And the label will be a 3. And then I'm going to go from M, so I can go over to N. And its label will be a 3. And then I can't go anywhere from L. So the first 3 alphabetically is C. So from C I'm going to go to H and to J. And they will both have labels 4. And I can't go anywhere from N. That won't create a cycle or isn't already labeled. So I'm going to go from H, which comes first alphabetically, and I can go to P. So P will get a 5. And I can also go from J to D and to K and to G and to Q. And so all 3 of those will get a 5. And from D, I can go to E, which will get a label of 6. So the difference is we're no longer saying 0 dash, 1A, 1F. We're just putting numbers and we're highlighting as we go. This is also called a shortest path tree. Not all graphs will have spanning trees. A graph is connected if and only if it has a spanning tree. This is a biconditional statement. It means a connected graph implies that there's a spanning tree, and a spanning tree implies that it's a connected graph. So we're going to just practice. So we're going from A. So A gets 0. And then we'll highlight. Well, the only place we can go is G. So G is a 1. And then we go everywhere we can. F, C, D, H. And they all get 2s. And the first 2 alphabetically is from C, so we're going to go over here to B. And this will get a 3. The next one is D. We'll go over to E. And F is the next one, so it comes down to J. And H is the next one, and it goes down to K. And we've done all the 2's, so now it's time to go back and do the 3's. Can't go anywhere from B because K already has a label. From E, I can go to M. Can't go anywhere from J. From K, I can go to P. And I'm done with the 3's. So now from the 4's, from M, I can go to L. And from P, I can go to N. And everybody's got a label, and there's our spanning tree. So why don't you pause the video and try to do number B, and I'll put the answer up, and then you can see it after you've tried it yourself. And there you have it.